Okay, so I'm going to record a video just to kind of explain how to create the cut and fill template for assignment 2. Just going over a couple of basics for Excel. So we're going to start off, we're doing the header. I'm sure that everyone can figure out how to do the name and section and title themselves. So we're just going to focus on some of the more technical stuff. We have grid number in our first cell, and then our second one, we have mark A, and then you can see that elevation in feet is underneath this. In order to get that, you press Alt and Enter, and then you have elevation in feet. And you can see that it adjusts the height of the row automatically. And we're going to do this for every single one. So we have mark B, and then do our average elevation. Again, Alt and Enter. And then again, Alt and Enter to get underneath. And this is showing us the formula that we're using. So we're doing B plus C plus D plus E, and then divide that by 4. And you can see that the parentheses are kind of shifted over. You can hover your mouse over the top here and then adjust the overall width, and it should finally move that over to where it's all in one row. And topsoil, then in parentheses existing, average, and again Alt and Enter for all these. And then this is something that we have to keep in mind. Professor Palmer is basically showing us what the operations are, F minus G, and this will become relevant later on whenever we're actually inputting all of the formulas for this assignment. And we have our finished floor, elevation in feet, and then slab, thickness in feet, carton, form, thickness in feet, and then our proposed final sub grade feet, and then I minus J minus K. Alright, our proposed minus our existing elevation difference in feet, which is element H, and then grid width in feet, grid length in feet, grid area in square feet. So now we're having a multiplication operation n times O, and cut in bank in cubic feet, also another multiplication, so m times p. This will basically get you your volumes that you will need, either positive or negative. Fill in bar, also in cubic feet, and times p. Okay, now just going to adjust how wide these are, just so we can have our rows in proper order. Then we can adjust the height. Okay. So Now we know that we have 33 boxes. I'm not going to go through all of them, but if you want a number, you can do this, highlight, and then there's a little box in the bottom right hand corner which you can drag, which then basically will number all of your cells for you automatically. Now, we do have cell 24A and 24B, so if I want to move this, I can hold the edge, move 25 down, and then I can write in 24A and 24B. These will have a different orientation, so in order to get these all centered, you can highlight and then center it in the column. So we have given values in the assignment sheet, and I suggest that you use these in order to double check your operations, because you will be using this to calculate all of your end results, and if you don't have these, then it's going to be a little bit more difficult to calculate everything. So just put in these values at first, and then don't forget to replace them at the end. Okay, and you can see that these, some have 3 decimal places, some don't. You can highlight the cells, and then you can increase the decimal, and then just adjust it to 3, so these will show up as .000. Now, for your average elevation, you want to add the A, B, and C, and D, and divide it by 4. So we're going to do this cell equals, and then in parentheses, this cell plus this plus this plus this, and then close your parentheses and then just divide by 4. Then you have your average elevation, and then here you want to have 3 decimal places as well. Our top cell is given to us as 0.333, and then here we can see that in the, it shows us F minus G, so we'll say this cell equals F minus G, and it'll spit out this number. Our finished floor elevation is 1058.500, and our slab thickness is 1.000. Slab's thickness is 0.667. Carton form thickness is 1.000. Our proposed, you can see, is I minus J minus K, so this cell equals I minus J minus K, and then our proposed minus existing equals L minus H. Our grid width, this just depends on how wide your grid is. For these first few, it's always 30, but if you're coming to the right hand side of the plans, you're going to need to do some adjusting. Now our grid area, we will have M times P, N times O. So we're going to do this equals N times O, and then our cut. So these last 2 boxes that we have are going to be a little bit more complicated, because just to use an if formatting to basically figure out if our proposed minus existing elevation difference is positive or negative in order to calculate the volume. So for a cut and bank, we're going to do an if operation, then you type in equals if, and then open your parentheses. And your logical test, we basically say if any condition is true, then it will do another operation. If else, then it will do another one. So we're going to say M2, which is our proposed minus existing. If that is less than 0, then we're going to do M2 times P2, right, because we're using this to find the volume, and then if it's false, we will just write 0. So you can see that this spits out 0 now, because we can see that our proposed mass existing is positive. We'll do the same thing here, but if our logical test, so we have if M2 is greater than 0, then we will do M2 times P2, and if that's not true, then it will spit out 0. Close your parentheses, and you can see it does your calculations. Now, obviously you don't want to do this for every single one of your cells that you have, so if you want to carry this operation through, you can highlight your cell, and then there's a little square in the bottom right hand corner that you can drag and pull down. Now these values obviously spit out nothing because we have nothing over here. You'll need to do this for every single operation. So starting from the left, we carry this through, and you can see that it highlights different values for us, and you can double check this with the sheet that Professor Palmer gave us. And you just carry this through all the way. Obviously you'll be going down to however many cells you have. But you need to do this with every single one so that it can spit out your final end calculation. And then you can see here it spits out the values, which are the ones that were given to us by Professor Palmer. And that should be it for everything that you're doing with this spreadsheet. Now, one last thing that we're going to do is format these cells, because in this assignment you can see that if it's 0, then they're highlighted as being red, and if it's not 0, they're blue. So this is called conditional formatting, and highlight cell rules. So if we say that our value is equal to 0, we can then click red text under conditional formatting, and you can see it changes this to red. Now if we do this over here, and we say highlight cell rules equal to 0, and then have red text, you can see that it only changes this value, not these. But we want anything that is not 0 to be blue, so we highlight these cells, again conditional formatting, highlight cell rules. Now this row, if it's less than 0, then we will have a custom format to where we then pick our color, and we can say blue, and it will save that. And here, do the same thing, highlight cell rules, but if it's greater than 0, then it will do a custom format, and then blue. And now you can see that it changes this, and if we had negative numbers here, then this would be blue as well.